So, hello everybody, nice to meet you. My name is Yohann Sillam, as Jane said. I'm working for Imperva company. And this talk is going to be about advanced bot landscape. So before we start, I'll give you a short introduction about myself. So, security researcher with 4 years of experience in cybersecurity. I spend the major part of my time analyzing malwares. But more recently, I spent time on web application security. I try to understand the advanced bot ecosystem, try to see their behavior, if there are ways to detect them or even block them. So this is the agenda of the session today. First, we will see together the advanced bot ecosystem. Then I will show you the internal structure of an advanced bot. And lastly, we will see together a few evasion techniques and the detection that we can provide. So let's go. But before we start, short definition of bots. Bots are softwares that automate action on the internet. There could be good bots, for example, the Google bot that's scrolling the web in order to improve its search engine result. And you have bad bots, for example, the ones that are scanning all in the internet in search of vulnerable websites. The difference between the two is the consent of the server being reached by those bots. For example, a bot that's not respecting the robots.txt file at the root of the website will definitely not be a good bot. Okay, so the market of bad bots is huge. The market, just talking about ticket scalping, it was estimated to be roughly $8 billion in 2017. And we can see that the market of bots is growing in general. Web scraper software market was valued to $500 million, and this was like almost this year. You have communities gathering hundreds of thousands of people, exchanging advices about bots, selling bots, buying bots, and there are many ones that I'm going to show you in this presentation. So this is such a huge market that very efficient bots can be very expensive. Here is the example of a bot called the Wrath AIO. Out of stock in its own website. And on the resale market, you can find it for no less than $1,700. Here, AIO means all-in-one. That is, this bot is able to scalp, actually it's an advanced scalping bot, to target all sites developed with the Shopify framework. Okay. So now let's talk about bot traffic in terms of numbers. So I've been spoiled a bit, but it's completely okay. Bad bot traffic was measured to be roughly a quarter of all internet traffic in 2020, where good bot is only representing 15% of it. And when we drill down into this, we can see that more than half of it is the fact of advanced bots. So what do we mean exactly by advanced bots? So we have a few things in mind. The first one is usage of headless browser technology. This is a technology that enables the rendering of web content almost the same way as a real browser would do. An example of such technology is Selenium, for example. We have in mind the rotation between anonymous proxies. Most of the time, they will be a residential one because they are harder to detect. And also advanced anti-detection mechanisms, for example, the ability to mimic human behavior during the solving of captcha. We'll see an example of that later. Okay, so what's the purpose of advanced bots? So they can be used for many things, including carding, the fact of checking stolen credit card numbers found, for example, in dark web and test it against e-commerce websites, credential stuffing, the fact of taking combo list of username and passwords from the dark web and check it against a large range of websites in order to find at least one match. Scalping, the fact of purchasing automatically a large amount of premium items from websites in order to resell it later at a higher price on the resale markets. So this damages the reputation of the e-commerce website and also generate a loss in the long term for the company because it destroys the strategy of premium items and generate frustration for the customer. Denial of inventory, the fact of for example, making a website unusable via the massive usage of dummy cards, and so on. So among all of those types of bot activities, scalping has become so popular that now it has become a kind of a sport. So this is a video taken from a YouTube channel called Botting with Burger, showing one guy using two different bots, advanced bots actually, in order to scalp the premium release of one specific company. So he's using on the left side a bot called Cyber.io, and on the right side, Torubot. So each of the lines that you can see, it's pretty difficult to see, I'm not sure if you see it well, is a scalping task operation. And their status is evolving. Initially, it's connecting to the website, then filling the form, and eventually solving the captcha and doing the purchase operation. So what you can see in the left, at some point, the lines turn green, which means that the full flow from the connecting to the page, monitoring of the price, and the solving of the captcha was entirely successful. And on the right side, you can see that it stays black. At the last stage, it's not possible to read because it's too small, but it says PX ban. This tells that the security vendor of the website was able to detect this traffic as non-legitimate and was able to block it. So this video is roughly a year old, and this shows that in real time, the bypass of a security vendor by advanced scalper, actually called Cyber.io. So I showed you this GIF in order to show you that this is an actual concern to be able to block this kind of traffic, block this kind of advanced softwares. Okay. So one of the challenges of this research was to get access to the files of the bots, because very often bots were out of stock in their own websites, and even sometimes on the resale market they were not available. So I list for you set sources that were very useful to me in this investigation. So first, you have general hacking forums. For example, Hack Forums, Crack.io, Null.2, Fraudster Crew, Sinstore.ly, all of those are hacking forums in general. And so you can search for a specific tool, or you can see new tools that are coming up. You'll have one post describing the tool, and most of the time, eventually, you'll have a link to an archive that's stored either to unknown files or megafile upload. You'll have, of course, to be careful, because those may give you a small gift. They may be also infected by malwares, so you should analyze it in a specific environment. Okay, so here are other kind of marketplaces that were very useful. So as I said, scalping has become extremely popular. Now you have even marketplaces that are dedicated for a type of scalping. Oh, shit. Okay. For example, ticket bots. So ticket scalping or sneaker scalping here. Okay. Sometimes we were able to get access to the source of a bot in GitHub. It was the case of Cyber.io, for example. Or behind misconfigured server, we were able to get access to the file of one advanced bot called KG.io. Okay, so once using all of those techniques, we were able to gather something like 40 advanced bots, so only advanced. We'll try to answer a few questions. What are the statistics in terms of programming language, in terms of headless browser technology? What's the internal structure of these bots? And what are the evasion techniques that they are using? So I'm going to show you this now. So the great majority of them were developed either with Electron framework, or even sometimes with a .NET written with .NET framework. And when we drill down and see what's the headless browser technology behind, we can see that Puppeteer is the most common headless browser technology used here. But we can see also other ones. Selenium is very popular, .NET browser, but we have also other ones like Essential Objects, Jigs browser, which is for Java, Playwright, etc. Now, let's look at the internal structure of an advanced bot. So, of course, there are many different bots, so it's not possible to do it for all of them, but the idea is to take the ones that are the most successful. So we go on Discord channel, we try to see which bots are the most expensive, the most recommended, and because Often, attackers break their outcome on those channels, say that they were able to scalp this and this premium release. So I decided to pick a bot called Project Destroyer. So a bit more than a year ago, it was worth $1,000. It has the ability to scalp all of those kind of websites that you can see here. And the reason I pick it is because it has many functionalities. So most of the evasion tricks that I will show at the last part of the presentation are part of this bot. But in general, the idea of bots are the same. Be able to connect to a website without being fingerprinted, be able to perform automated actions in a simultaneous way at a very fast pace. So we could split. This is a very simple version of this bot. So we could split in the left side what's the input, what we provide to this bot, and on the right side what is inside of the bot. So to be provided to the bot a list of proxies, so usually IP port, username and password, a valid key for a captcha solving service, for example, capmonster, a list of profiles, so including billing information, names, addresses, etc. The attacker may have several ones. And then inside of the bot, you have the headless browser. So in this case, it was a Puppeteer. Usually, you'll have also additional modules that will improve its ability not to be detected. For example, in this case, a Puppeteer extra plugin stealth. Then you have an evasion module that will be responsible for all of the tricks to make the bot hard to detect. You have a profile management module that's responsible for storing the profile provided by the attacker. Proxy management module that will be responsible to store the proxies, check if they are valid, measure the speed, and solve them according to it. You have a cookie jar. So it's an interface provided to the attacker to generate valid cookies for the target website. So most of the time, 24 hours up to 48 hours before the release of primary items, the attacker will have to generate a batch of cookies, and then they will be consumed during the scalping operations. You have a captcha management module that will be responsible for extracting the captcha from the page, send it to the third-party service, and then retrieve the answer and solve it in the client side. And you have the operation module. So in the operation module, most of the time you have one folder for each target victim that you have. For example, in the case of Project Destroyer, you have 37 folders. So it will contain the script in order to click on a specific button, to fill a form, etc., and then to call the other components. Okay, so let's zoom in and see what happens in one specific task. So the headless browser here, Puppeteer, is started with, as I said, a feature in order to make it harder to detect. For example, set the WebDriver to false. Then the bot will craft plausible device attributes for the bot to look like a real device. I will show some examples just later. Then the bot will pick pre-generated cookies and proxy for the specific target. Then the bot will monitor the price of the premium item that it wants to purchase in a loop. If at some point the price is below the threshold that is set by the attacker in the task, then the purchase operation will happen. When the captcha is provided to the bot, it will be sent to the third party, and the captcha will be solved. Okay. So now let's look at a few evasion techniques and some detections that we can provide. First of all, it's not actually evasion, it's code protection. So the code of this bot was quite strongly obfuscated. When you try to expand it this way and execute it, you will crash with this specific error. So what actually the code does, it checks the difference of string representation of functions when the code is non-touched and when the code is being debugged. So I had to understand which part of the code was responsible for this check, disable it, and then I was able to detect the other tricks used by the bot that I'm going to show you now. So one of the tricks that they used was to add non-mandatory HTTP headers to the fields of the requests. So here, for example, you have a list of 7 different fields that are non-mandatory HTTP header fields. And there are randomly a certain number of those fields are added to the request that will be sent for one specific scalping task. So this is done in order to make the bot looks like a slightly different device each time it's performing a scalping operation. So this is not actually JavaScript code. I deobfuscate it and show it in like pseudocode. Okay, another small trick that's worth mentioning, it's called address jigging. So the bot is extracting the addresses provided by the attacker, and then it's parsing it and finding the keywords associated to roads, avenues, lanes, streets, etc., and then slightly modifying it in order for all of the scalping tasks, even though they're directing to the same address, eventually to look different for any security device that would try to find scalping operations. For example, there is another function that will add a leading 0 before the numbers of the addresses. Okay. Another important topic that can be discussed related to advanced bots is the ability to stack captcha solving services. For example, there is a new tool called AYCD AutoSolve that can be integrated with some advanced bot, including CyberIO, for example, that enables the attacker to prioritize different captcha solving service. For example, first the captcha will be sent to CapMonster, and if the captcha cannot be solved by this specific service, it will jump to the next one, and so on. This maximizes the probability that eventually the scalping operation will be successful. Okay, so now let's look at a few detections that we can provide for this bot. So inside of the code, I was able to spot this specific section that's responsible for crafting device attributes plausible for the bot. So here you see the available height. So this is supposed to represent the size of the screen of the device, not the size of the window. And it's set to be a random number between 1,000 and 1,600 pixels. But it's like uniformly randomized. So there are values here that don't correspond to any device on the planet, most likely, because it's really precise. So if someone is really paying attention to what happens on the specific device, he will be able to detect that this is probably not a real device, but a bot. So this is a flaw in the code of the bot. As I say here in the documentation, this is the size of the screen. Another thing that we can do is extract the snippet of code responsible for the solving of captcha in the client side. So eventually, the bot is using a function that will generate a busy curve in order to solve the captcha. So this is more or less how it will look like. So you can see the curvature is pretty smartly done. You can see the acceleration, the deceleration. So a simple device will not be able to detect this as illegitimate. But if you pay more attention, you can see that a real human will not draw curves like this. It will be more irregular. So we tried to check if it was actually true, if we were able to see a difference between real traffic and fake traffic. So to do so, we decided to measure the acceleration of the curve. So this is the graph that we obtained. We can see that the average is set to 0.1 pixel per millimeter square, with a maximum value to roughly 0.15. So we try to do the same with human curves. And this is more or less the graph that we obtained, with an average higher up to 0.15 and a maximum to 0.5. So the question here is not if we can detect bots using this kind of technique. This bot actually using this kind of technique is how much time do we need in order to be accurate enough to be sure that this is indeed a bot. Okay, so as a conclusion, the malicious of market bots is large and expanding today. Then there is a predominance of Electron framework for bot development and Puppeteer as a headless browser technology. And lastly, it's a cat and mouse game, which means that knowing the code of the opponent, be able to understand the tricks that he's using is a great advantage in order to help the for the detection of those tools. That's it. Are there any questions?
So, do we have any questions for Yohann and the bad bots? Silence. I actually have a question about one of your slides. Could you go back to the slide where you had the captcha services, the captcha beating services, or whatever they were? There was a list.
The list.
Yeah. There it is.
This? Okay.
Yeah, this one. So I'm looking at them, and there are 3 there, and on the right-hand side there is balance, 049 984. What is the balance for?
So the attacker has to register for each of the services that he will integrate with AOSCD Autosolve. So he'll have to pay for each of those services, and then each time they are requested, then the balance will decrease. So when the balance is set to 0, so you cannot use this service. So probably it will skip automatically to the next one.
Okay. So then do these services cost different, like per time of use? Is there a different price between the different services, or are they roughly the same?
So the prices are roughly the same. They can vary a bit, but more or less it's something like open $1 for each request, something like that.
Okay, interesting. And then you talked a lot about scalping in your presentation, and to me, I'm very old-fashioned. Scalping to me is where I go to a concert and there's somebody standing outside holding tickets up and saying, "Please buy my tickets," and the concert is sold out, and I pay a bunch of money for that. What does scalping mean in sort of this realm, in the bot world?
I said that scalping is okay. It damages the. So first, it's something that's almost everywhere in the market of bots, and actually, this is where the most advanced we can find the most advanced bots, because they need to have a very strong interaction with the website. It's not only about like sending one request. It needs to keep a communication, be able to move from page to page without being spotted as malicious bots. So as I said, scalping damages the reputation of companies when they're successfully attacked. And that's why companies really try to invest in order to be able to protect against those threats. So this is why this presentation is like slightly oriented with scalping bots, let's say. Okay.
And then what is the target then of a bot that is engaging in scalping?
What's the target?
Yeah, what is the
so there are many targets, so I show a few of them. So for example, all websites developed with Shopify frameworks, but there are Amazon, of course, eBay, Walmart, Adidas also. I mean, if you go to any of the markets that was listed above, you can see the list for each of the bots that you want to purchase. You will see the list of targets that it has the ability to attack.
Okay. I think we have another question up here.
Yeah. Yeah. Thanks for your talk. And I got a question about bot protection. I work on a software as a service product, which is very, very attractive for people who are trying logins from database leaks. And for us, the invisible reCAPTCHA from Google was the only solution to protect our login against bots and automated attacks. Do you know how safe they are? Like reCAPTCHA, I think it's top of the notch, or one of the top of the notch solutions. But do you have any experience?
So reCAPTCHA is relatively strong, but of course, I mean, there are always the machine learning tools that are currently used by third-party captcha services are stronger and stronger. Even at some point, what they do is they just automatically send it to a specific person that will solve it manually. So this is, I think, the case. You have like a tool called Death Captcha that's doing both of it. It's so if the captcha is simple, it solves it with machine learning. If not, it sends it to someone, usually in India, that will solve it. So it's an ongoing challenge to be able to improve captcha strength. But there are many different ways to try to detect bots, not only about like captcha. This is like the end solution that actually companies now are trying to avoid because it's time consuming also for the consumer. It's bad user experience.
Thanks.
Hi. You talked about randomizing or pseudonymizing the shipping address for some scalper that is trying to buy all the sneakers on the market for whatever. Has anyone tried talking to the shipping guys of UPS and stuff like that? Because it sounds like an integration with those guys can provide a feedback loop to actually detect that.
So this is an interesting topic. I don't think that. Okay, so it's probably below. I don't think that this is something that we did. Indeed, this is something that can be done. But I mean, I assume that people are sometimes writing shortcuts for also addresses, so it may lead to false positive. One option probably would be in the logs of the so propose a service for the website to aggregate the logs and check if there are any aggregation that can lead to detection of scalping operation. This is something that can be done eventually more at the level of the log analysis.
Okay, thanks.
Do we have any other questions for Yohann? All right, okay, go for it.
Hi. So with this technique, let's say a professional scalper, so to say, what quantity of product might this person be looking at, and then how this person actually gets then things?
What's the quantity? Sometimes it can go up to 50 different boxes of, let's say, sneakers that cost each of them $100 or even, I don't know, a bit more. So it can be sold at much higher price. So you can see on resale markets for specific brands, the prices of items can go up to $1,000. So when you have 50 bucks, so you multiply the two numbers, it can make like a very large amount of money. So this also explains the price of the bot that I showed you. Prath.io, $2,000. This is an investment, but eventually, sometime it pays off.
All right, we are getting to the end of our time, so please give Yohann a round of applause for Bad Bots.